Okay, today we are going to review the entire worksheet so that you have an example of every problem so that you can go through and practice before you have to take your quiz. So this first section that we're going to be looking at today is going to be about special right triangles. We have a set of problems right here that all have 45, 45, 90 and 30, 60, 90. You can see that in their measurements. It also tells you specifically in the directions that no decimals are allowed. The answers must be exact. If that's true, you know you can't use trig, because trig is all rounding, all decimals, all estimates. So therefore you know you have to use special right triangles. You also see those measurements that fit those special right triangles. So that's how you identify those problems on the actual quiz. In this case, this is a 45, 45, 90 triangle. That means the two legs will be the same distance. That means the x will also be 7. To find the length of the hypotenuse in a 45, 45, 90, you are going to take and multiply, because you're getting bigger, by the radical 2. That's just going to be written 7 square roots of 2. Now, on a 30, 60, 90, which is the 60, the short leg is always across from the 30-degree angle, so we identify that short leg before we do anything. Currently, we have the hypotenuse in a 30, 60, 90. When you have the hypotenuse, to move from the hypotenuse back to the short leg and make it smaller, you are going to divide by 2. That's going to make this 13. And then to go from the short leg to the long leg, we are going to be multiplying because we're going to be making it bigger. And remember, whenever you go past this right angle symbol in a 30, 60, 90, you are going to be dealing with that radical 3. So we would write that as 13 square roots of 3. From there, we're going to move down to the next. And I'm going to pull it up, guys, just because I want to keep it towards the top. I don't want anything to get cut off at the bottom. For the next problem, we're going to be looking at another 30, 60, 90. In this problem, you're dealing with the long leg. I know that because if I look at the numbers, that's across my bigger angle right here. So again, identifying that this is your 30, that makes this one your short leg. I want to go from the long leg to the short leg. To do that, I'm going to be dividing by, and again, since I'm going over this right angle symbol, I'm going to be dividing by root 3. Radical 3. So if I take and I do 7 square roots of 3 divided by the square root of 3, those two are going to cancel, and I'm going to be left with just the 7, just by itself. So 7 is going to be my short leg. To go from my short leg to the hypotenuse, I'm making it bigger, so I'm multiplying, and the number would be 2. So 7 times 2 would put my hypotenuse right here, my y, at 14. We're back to a 45, 45, 90 on this one. We can tell that because we have 145 and 190. If you do the math, you can figure out this one is 45. That means the legs will be the same. If the legs are going to be the same, to go from the leg to the hypotenuse, we would be multiplying, because we're getting bigger, by radical 2. That's the only number in a 45, 45, 90. So that would be 6 square roots of 2. Oh, and don't forget, guys, if this one's 6, the other leg is 6. Okay, let's pull that up. For the next one, we've got a 45, 45, 90. When we deal with this, these two would be the same. Again, you can identify that 45 if it helps you. That 8 square roots of 2 is going to be repeated here because they have to be congruent to each other. We're going to take and we're going to multiply. Again, guys, if you're going towards the hypotenuse, you're making it bigger. You're going to multiply by that radical 2. This one's going to be a little unique because you've got 8 square roots of 2 times the square root of 2. When you multiply a radical by itself, you get that number without any symbol over it. Think about it. The square root of 2 times square root of 2 would be the square root of 4. But the square root of 4 is just 2. So really what you're doing is 8 times 2, which puts that at 16. Okay, for the last special right triangle, we have a 30, 60, 90. On this 30, 60, 90, we can identify our 60. This 30 is going to be across from our short leg. This is going to be the one that requires you to deal with that radical on the bottom of a fraction, so pay attention. So we've got this 15 right here. This 15 is the long leg. We need to go from the long leg to the short leg. To do that, we're going over the right angle symbol and we're making it smaller. So we're going to divide by the square root of 3. If I cut down here and show you the math, excuse me. So again, if you come down here and go ahead and try to divide that 15 over the square root of 3, we have to get rid of this radical that's on the bottom, so we multiply by the exact same thing that's on the bottom, on top and bottom, because really that's like multiplying by 1. When we do that, we're going to go ahead and multiply that and get 15 square root of 3 all over 3. Now you do need to simplify this if you can. 3 will go into 3 one time. 3 will go into 15 5 times, and remember, anything over 1 just reduces to that number, so it would just be 5 square roots of 3. That would be my short leg. Then to go from my short leg to the hypotenuse, I'm making it bigger, so I'm multiplying, and that number would be 2. If I need to multiply 5 square roots of 3 times 2, remember, I'm multiplying the numbers on the outside. That's going to be 10. And I'm treating this radical 3 like it's a variable. I'm just putting it right after it at 10 square roots of 3. That would be my hypotenuse. Okay, so those are all our special right triangle problems. The next set is going to be our Pythagorean theorem problems. Let's take a look at these and see what we need to do. I'm going to pause for a second and pull it up and clear this off. Just because I want y'all not to have anything cut off at the bottom, guys. So give me just a second. There we go. Okay, so here we go. Let's get going. So we're supposed to use Pythagorean theorem. Guys, just because you see a radical, don't start looking for special right triangles. If it says use Pythagorean theorem, you've got to use it. That's that a squared plus b squared equals c squared. A squared plus b squared equals c squared. And remember, it's going to be rounded to the nearest hundredth, and it'll have that specific direction for it on the actual quiz. Like each individual problem tells you what to do on it. So make sure you read that. So as we take a look at this one, we're going to start off, these are the legs. They need to go first. It doesn't matter what order they come in. 2 square roots of 3. Squared plus 10 squared equals x squared. Remember, you can do the math for this on a calculator if you can type it correctly, but the easiest way to multiply this is to multiply the outside number twice and the inside number once. So that would be 2 times 2 is 4, and 4 times 3 would be 12. Plus 10 squared is going to be 100, equal to x squared. You'd add those together, that'd be 112 is equal to x squared, and when you take the square root of 112, that is going to round to 10.58 equals x. Again, the reason it does that, when you do the square root of 112, that's going to give you, decimal-wise, 10.583. Remember, that 8, we look behind it. Since the number behind it was 4 or below, you leave it the same. So that x ends up being 10.58. For the next one, again, remembering that you've got to keep the one that is the hypotenuse on the side by itself. So when you do this one, the hypotenuse is going to be an actual number, not the variable. So in this case, it's going to be x squared plus 5 squared, the 2 legs, in any order. It could be 5 squared plus x squared. and that would be equal to 13 squared. That's going to be x squared plus 25 equals 169. You're going to subtract that 25 from both sides. That's going to put it at x squared equals 144. And this one's a little bit easier because this one is a perfect square. So when you take the square root of both sides, x is just going to equal 12. No rounding, no issues. That's the answer. Okay. So I'm going to have to clear it off to pull it back down. So let me go ahead and get that done so I can move to the next set. See if it'll, yeah, I'm going to have to pull it down. Give me a second there. Okay. So we're going to be simplifying in simplest radical form. In order to do that, we need to break this apart into a radical that is a perfect square and then what's left over. When you start dividing that 192, you can break that down into lots of things, but if you look at the biggest thing that will go into 192, it will divide evenly by 64. Right? 192 divided by 64 would be 3. 64 and 3, and the square root of 64 is going to be 8 square roots of 3. Now, personally, I did not see that the first time that I worked through this problem. I want to show you so that you understand there are other ways to get there. The square root of 192, I started off dividing this one by, I think I did 4 first. Yes, 4. So I did 4 first, and when I divided by 4, that gave me 48 over here. Right? And then when I did 4, that's going to be 2 square roots of 48. Now, I recognize that 48 then could divide by 16. You could do by 4 again, but you'd have to keep going. I recognize, though, that 48 would divide by 16. So I did 2 times the square root of 16 times the square root of 3. When you take the square root of 16, that's going to be 4. And remember that you've got to multiply the numbers that are outside the radicals. That's going to give you 8 square roots of 3. Notice I end up with the same answer. I just took 2 different approaches. It is okay to do that. Okay? Same thing on the next one. Now, I recognized it right away because I use this number a lot. You may not. You may have to break it down several times, but just make sure you simplify it all the way. For 288, 288 will divide by the square root of 144 and the square root of 2. The square root of 144 is 12 square roots of 2. Again, all I did was take the square root of this, put it out in front. Now, 147 is one that took me a minute. We did this, I think, on one of our sets of notes, maybe. One on the worksheet, I can't remember which one it was. But 147 always gets me. Guys, I had to divide until I got there. It will divide by 49 and the square root of 3. And the square root of 49 is 7, so you would write your answer as 7 square roots of 3. Okay. So our last problems on the front side are going to be problems that are dealing with sine, cosine, and tangent, just writing those as ratios and then as decimals. So let me clear this off and go ahead and pull this down. I think I'm going to, oh no. Yeah, I should be able to see it. That should be good. We can see the problem and still see the problems that are below, like the picture, and still see the problems below it. So we are going to be doing the sine, cosine, tangent of A, and then also the tangent of C. You have to watch the variable that you're talking about here because that's going to tell you what corner to come off of. The first 3 come off this corner right here at the top. Because they're looking for these trig ratios and they're looking for them in fraction and as a decimal rounded to the nearest hundredth, we're going to have to make sure we give both of those answers. Make sure on the quiz you read which one it's asking for. So if we're looking for sine, remember sine is going to be SOH. That is opposite over hypotenuse. The opposite side from A is going to be 10. over the hypotenuse, which, guys, the hypotenuse never changes. This is always the hypotenuse. Doesn't matter which side you're on, which angle you're on, anything. So that's going to be 26. Use your calculator to reduce that. If you type 10, fraction button 26, it equals. It will reduce that down to 5 over 13. You're also going to give me the decimal form of that. On your calculator, you can just hit second and the little button that's right at the very bottom on the left-hand side that'll change it to fraction and decimal. That's going to give you a decimal rounded to the nearest hundredth of 0.38. All right. For cosine, the abbreviation for that is CAH. So for cosine of A, we're looking for the adjacent side, which would be 24, over the hypotenuse, which we already said was 26. The hypotenuse never changes. And 24 over 26 reduces to 12 over 13. When you turn that into a decimal and round it to the nearest hundredth, that's going to be 0.92. Okay, tangent is TOA. So we're looking for opposite over adjacent for this. So the opposite side is going to be 10. The adjacent side to that A is going to be 24. And when you reduce that, that's going to reduce down to 5 over 12. The decimal form of that, rounded to the nearest hundredth, is going to be giving us 0.42. 0.42. Yep, the one with the 6 after it rounds up. Okay, last one comes from a different angle. This is the angle we're now looking at. You have to know what letter we're talking about. Tangent of C. It's still TOA, but opposite of C is going to be 24, and adjacent to C is going to be 10. That's going to reduce down to 12 over 5. And the decimal for that is actually a decimal that terminates, meaning it ends. You don't have to round it. It gives you a decimal of 2.4. Okay, guys. So that's everything on the front. Let's go ahead and knock out the back side and get y'all ready for your quiz. Okay, so these are going to be our trig problems. We're looking for one piece, either a side or an angle. When we deal with the angles, remember we're dealing with those inverse functions, so we've got to remember how to set that up when we do the -1. Okay, now before we get started on this, remember that we're dealing with SOH, S-O-H, CA, C-A-H, TOA, T-O-A. So when we look at this first function, we're dealing with the opposite side and the hypotenuse. That means you're going to be dealing with sine, so you would write sine of, it's always the angle when you put the sign, guys. Sine of x is equal to the opposite, 13, over the hypotenuse, 24. Whenever you have a problem like this, you rewrite it as sine -1, the inverse of that. You move these two and switch them. What you're doing is switching the x and this fraction over here. So put the 13 over 24 here. Put the x on the other side. To type this, you are going to type second oh wait, no, y'all have the backwards calculator, so y'all have to do it the other way. Let's try that again. So to type this on your calculator, I have a different calculator than y'all. You are going to type 13 fraction button 24, and then you're going to hit second sine. That's going to give you on the calculator 32.7 equals x. And remember, when we're doing these problems where we're looking for an angle, we're rounding to the nearest degree. That means the nearest whole number. So it's got a 2 with a 7 after it, so we need to round up. So that would make that 33 degrees. That angle right there would be 33. Okay, for the next one, we're looking for a side length now. When we're looking for a side length, we still do the same thing. We find the relationship. That's going to be from this angle, the opposite side and the adjacent side. When we have opposite and adjacent, we'll be dealing with TOA, with tangent. So that's going to be the tangent of 33, the angle goes right behind the word, equals the opposite side, 18, over the adjacent side, x. Whenever the variable is on the bottom like this, you are going to switch everything from here to the bottom right here. You're going to put the x equals, and you're going to write 18 over tan 33. So let's go ahead and try this. So it's going to be 18 divided by 33 tangent equals. You got to make sure you hit the equals button, guys. Don't forget about that. So to type this one in, it would be 18 divided by 33 tangent equals. 18 divided by 33 tangent equals. On the calculator, that's going to give you 27.717. We're looking to round to the nearest hundredth when we're dealing with a side length. So a 1 with a 7 after it would round to a 2. So my final answer would be 27.72. So from there, again, because of this, I'm going to slide this all the way up. Again, you can pause if you're still writing, but let me go ahead and move it up so I can see these next two. So these next two are going to be problems where we're doing sine, cosine, or tangent again. When we're looking at this, we've got this angle that has the adjacent side and the hypotenuse. If we have adjacent and hypotenuse, we'd be dealing with the cosine. So the cosine of 14 is going to be equal to the adjacent side, 47, over the hypotenuse, x. Remember, when x is on the bottom, you switch them. That makes it x equals 47 over cosine of 14. So from there, it's going to be dividing that. 47 divided by 14 cosine equals, gotta hit equals. That's going to put it at 48.438. I'm going to put it right here just so you have x equals 43.438. Now a 3 right here with an 8 after it is going to round to 43.44 for that side length. Okay, so this is the last one I'm going to work out. Now these will be bonus problems. I'll give you the answers, but these are bonus problems on your quiz, so I'm not going to work through every one problem by problem like I did on all the others. I'll go over them after I come back if you still have a question, but we're going to be doing more and more of these. So this is the last one I'm working all the details out on. So this is going to be an angle problem. So from here, we're going to be dealing with the opposite side and the adjacent side. When we do that, that's going to be dealing with TOA. So that's going to be tangent of x is going to be equal to the opposite side, 22, over the adjacent side, 86. Whenever you have one like this where you're finding the angle, you're switching whatever's here with whatever's here. So that's going to be tan 22 over 86 equals x. And again, to type this, the way you type this one on your calculators is going to be 22, fraction button, 86. And then you hit the second and, in this case, tangent. When you do that, that's going to give you 14.3 equals x. Remember, we're rounding to the nearest whole number, and I'm looking at the number behind it, so that would round to 14